Hello, QST readers worldwide. I'm Dave Casler, amateur radio call sign KE0OG. I am the author of the Ask Dave column in QST, and every month I add a supplemental video to one of the questions in QST. This is the supplemental video for October. The column in question is the one in the October QST of 2023. It's about antennas, as are most of the columns have got antenna stories in it. It truly is the most popular topic in ham radio for people to ask questions about. The question originally came from Lawrence Logston, WD8MWS. He has several questions in here. Does he need to make each leg a little bit longer in order to make a fan dipole? The answer is no. But you do keep a little bit extra on there so you can wrap it back and change it for tuning purposes. He says he's using a 4-to-1 balun and a 20-foot coax coiled choke with RG58. You can use either one of those. You don't need both. Or you can go with neither. Will wrapping the coax cable around the center mass create issues? Actually, no. What is inside the coax stays in the coax right here. Now this is the picture that was in QST. There are no dimensions. So my assistant and I decided we would build one. Here's our calculations. It's strictly 468 feet divided by F in megahertz gives you the length. And this assumes a 95% propagation factor in a wire, which is a good assumption. So 66 feet, 33 feet, 16.5 feet total. And what we decided to do was make an antenna that looks like this. It's got, the wires are run along each other. We've got a longer spacer here and here to handle all three wires. And then here and here, a little bit shorter to handle the two wires. So the long element's 40 meters, then 20 meters in the middle, 10 meters at the top, okay? That's a nice little lenticular cloud that's not yet fully formed. Okay, let's see how we made the thing. We start with my assistant, who is Aiden, who is using this white stranded wire from Home Depot. These are the pieces of plastic that he's cut with this pipe cutter right here. We could not find my pipe slicer. I've got one, I just don't know where it is. So we did we did our best with what we had, which is normal. So here he's drilling the end holes and one of the longer ones, drilling the middle hole in here. This hole is sized to be enough for the wire to slip through, but if you put a little bit of a kink in the wire, it'll keep the thing from slipping through. Here is Aiden wrapping the ends of the wires together. He's pulled off several inches off the end of each wire. This is the part that will go on the insulator. Now, what we did was we first tinned those. You can see our little insulators down here. I used a torch, as that's a pretty thick piece of wire. Now, I will tell you that the torch was too much energy. We should have ramped it down quite a bit, but it worked. Now, here is the SO239. We decided to do that so we could use my standard test coax to connect to it. There is not much room in here. This does not go down in a hole. It just sits right there in that little tray. So we taped this down. My assistant held his hand on it with a kitchen hot pad so that it wouldn't hurt his hands as that thing got hot. And we got that all taken care of. You can see it right here. It's all soldered in nicely. The other wire is soldered to one of the 4 holes. And this is our electric fence insulator. This one goes vertically, this one goes horizontally around a common center. And this is after we attached it. So you see the center is attached to one side and the shield is attached to the other. Is that best practice? I guess best practice is a balun of some kind, but this worked really well. So we didn't need that. Okay, so this is what he's going to take out. He's got the 3 wires on each end of this, and he's out there measuring a distance from our new 30-foot test mast, and we're going to get it so that it's, we're trying for 120 degrees at the center. It ended up with the sloping about 90, but it works. So here he is tying the end of the 40-meter element to the rope that we're going to use, and then that rope was attached around a stake. Notice I put a little safety slab on top of this. It's a 2-foot stake. And then you get a picture here of the rope. It wraps several times around the stake, and it comes out here for a simple knot. So let's look at the test results captured with my Nano VNA. Here's 40 meters, 20 meters, and 10 meters. Note that we seem to have a freebie on 15 meters. That's because this thing is resonant on 40, and this is the 3rd harmonic of 40 meters. Now let's get a little bit closer look at each band. In the 40-meter band, we do get down to 1-to-1 SWR here, and it's under 2-to-1 across the entire band, which is excellent. This is 20 meters. It resonates a little low here. We could have taken a couple inches maybe off each end of the 20 meter and moved this one over here, but it was under 2-to-1, so we stopped while we were ahead. This is the 10-meter one. It's not fantastic. You could move this around in the band if you wanted to get, say, this part down here to the bottom where most people are working. And so the antenna is too short, so you would have to lengthen it, but we've wrapped some wire back so you can do that. Now here's our 15-meter freebie. It is under 3-to-1 across the band, under 2-to-1 for part of it. It's not perfect, but you can tune it on 15 meters and work just fine. Here is a listening test using my software-defined radio called the SDR Play RSP1A, Radio Signal Processor 1A. Okay, and the software is SDR Uno, which is SDR Play's house software. And I cut the picture in half so that you could look up here at the new tri-band antenna and down here at my reference step IR, big IR, which is a vertical with lots and lots of radials. Very nice antenna. Now I'm comparing horizontal antenna with a vertical antenna, which is not fair, but I don't have another horizontal antenna to compare it with. Also, these two snapshots were taken 1 minute and 45 seconds apart. And the reason for that is the process to go through and capture the screen on this one and then back out and do the processes to set up capturing the screen for this one take 1 minute and 45 seconds. Now, I do have an SDR Duo, and I will need to hook that up so I can snap these at the same time. I'll get that set up. Okay, here is some FT8 on the new antenna. Pretty good results here. In some points I receive a higher report than the one that I sent, and in other cases the other way around. So that's pretty normal. There's 8 contacts here. One in Canada, the others spread across the western United States pretty well. Okay, so let's conclude with one last look at the antenna. We have the 10-meter element here with a little wire bent back, so you can adjust that. You can adjust the 20-meter element a bit, and you can adjust the 40 a bit. And we never did adjust the 10. We adjusted the 20 twice and the 40 twice. And if you did another round of adjustments, you could get this thing even closer. Now, it's interesting to note up here at the top The thing is actually held up by the coax. I've got a rope around the coax that tightens on it. That way we're not putting a lot of strain on that little SO239, but actually it's holding up the coax right there. So there you have it. We have successfully constructed an inverted V fan antenna for 40, 20, and 10, and 15 comes along for the ride. So we've got, in essence, a 4-band antenna here. Now, because it is an inverted V, it will have a slightly more unified pattern around it than would a dipole. Okay? Now this will work very well. We have it up nearly 30 feet on this 30-foot mast that we put all the way up. It works very, very well. The thing is sturdy as can be. You could put 100 watts out on this antenna. You could put 1,500 watts out on this antenna. There are no power limitations because we use number 12 wire to make this thing. And these little, the wire was from Home Depot. The plastic pipe that we cut up for the standoffs was from Home Depot. The only thing that was not from Home Depot was the SO239 connector, which I got off of Amazon. So there you have it. I hope you enjoyed that. If you would like to see my channel on YouTube, you can go to youtube.com/Dave Casler, all one word, DAVECASLER, all one word, and check out the videos there. This video is associated with the column, so let's do just a little bit of advertising for the League. As we sign off, I might mention this came today from the League. It's a brand new book, Radio Wave Propagation. I'm looking forward to reading it, and I hope you would like that something too. So, until we next meet, 73.